Hello. And intro to most of my instructional videos here is going to be just some basic things to keep in mind. One, I record and I record my videos and post them to YouTube so you can use closed captioning. I know I tend to talk a little fast, so hopefully this will help. You can see down at the bottom of the screen here what you can see in English what I'm saying. The other thing you can do with closed captioning is if you want to see it in another language, let's say you can read Ukrainian or you can read Spanish or Filipino. Oftentimes YouTube will allow you to do closed captioning in another language, so that can be helpful there. That's a resource there. The other thing as you're watching these is pause. Don't be afraid to pause the video. Write down what you're doing or write down your question and then restart it again. That's something that's a little bit different than in class because I know I do tend to talk fast. All right, as you're watching these videos, I want you to break it into 3 parts. Part number 1 is to watch that video all the way through, get an idea of where you're going. What are the expectations? What is it you're going to be doing? If possible, what's the end product? What's the end result you're putting there? What is it you need to have done? Second is to put together a notes, and that's where you're taking these on paper and pencil. I know a lot of you like to take notes digitally or want to take notes digitally. It's not the same. I really encourage you do it as your handwriting. It helps with making that connection between the brain and what's going on. And as you're taking notes, take notes on things instructions that I give you. Write out those instructions. If I give you hints or tips, write those down. If there's important measurement information or details, write those down. Also, questions, write down your questions. Words you don't understand, directions that don't make sense, things I don't demonstrate. Those are great. Write those off I would encourage you, write those off to the side in the margin. And then the next step, third time you watch the video, is go back, watch for things, do I answer the questions you have? Look for the answers to those questions. Because any questions that are left afterwards, that's when you can email me at my email address that hopefully will pop up here if I do it right. Or you can save them for when we're in class. All right, so hopefully these tips and instructions are going to be helpful, and I look forward to helping and supporting you. So let's go ahead and get started. And as I always say, let's go forth and do some great things. Hey, good afternoon, good morning, good evening, good after morning, good after evening, good middle of the night, good middle of the day, good noon to you whenever you may be seeing this. For me, it's afternoon, and I hope to get through this quickly because it's 80 degrees outside, and I want to get outside and have a water balloon fight with my kids. So I'm not going to try to rush through this, but I would say take this in steps, get outside and do something fun. All right, so to start off with, we're going to do a quick review. We're going to be working in the City of Angels. Crystal Crater is the group of lessons. You can see there are 11 lessons. I got some great feedback from your friends. Do we have to do all the activities was the biggest thing. And unfortunately, yes. For those, and the reason why is they give you practice doing each thing more than once, so that when you get down to the higher level lessons, you've got a good understanding of how to apply things. I'm going to start looking ahead and seeing though if there are some things that we can skip. But it is important that for right now you do the whole thing. As far as some other feedback, I'm going to try to make sure that I keep putting this into sections as to not overwhelm you. Let's see here, and there's going to be with this lesson, there's going to be a lot of resources that are included in Google Classroom for you, because we're starting to talk about angles and pulling in some geometries. So again, as I told you at the beginning of the semester, I'm the glue as to why this class is the glue as to why you have to learn all this stuff. This is where we start putting in geometry, angles, and math and stuff like that. So very quickly though, I want to review a few things. First thing is the use of data blocks. And I'm going to pop this lesson open here. And you can see I've got my code here. And, this little data blocks are right here. So I'm just going to pull this out and delete it. And, a lot of you have been asking, I've got a lot of people that are asking, where do I get the data blocks? How do I put them in? Remember, to do a data block, you're going to hit the little square, hit that there, and set that to, you want to set the distance. You hit the gear there, and you're going to want to set the angle. Okay? And then your data block, all it is simply just a block that allows you to put in numbers for things. Excuse me. The way I like to think of data blocks is they're variables. You could think of these as unknowns, or x or y or whatever in your equations. So, you know, I want to go forward 7 and go for a 39-degree angle. Okay, so that's the review of data blocks, and you know, also how to add them. The next thing I want to review is flow control. And as we talked about in the other lessons, and I'm just going to pull these two out here. These are your two flow control blocks. Remember, these are the punctuation. These are the things that they're like stop signs or commas or periods. They control how your robot or how the computer moves through the program. So you could think of this wait for block, wait for 1,000 milliseconds. So that would be 1 second. So you could say, drive forward 7 blocks or 7 meters, wait 1 second, then turn to the left. And so that's kind of how that works. Now, let's say we wanted to repeat or do this code over and over and over again. Well, that's where the repeat block comes in. This allows you to say, you know what, I want to repeat this 9 times. And then it'll go through and it'll count these things 9 times. So right now we're working just with numbers, but you can do some repeats and wait fors and flow control based on sensors, which not necessarily going to get into in this class, but maybe later on you'll get into that. Okay, so before I get going here, I'm going to actually restart that, and then I'm going to go, let's see here, I'm going to go back out to here. Before I go into, pseudocode. That was the last thing I wanted to review. Remember, pseudocode is the rough draft of the program. So as I jump back into the review here, so you can see I'm going to be doing some pseudocode review for activity 1, and I'll do that in part 1. But just remember, pseudocode it's that rough draft where you're telling the robot, you're kind of writing down into plain English instructions for the robot. So for example, you know, maybe I go robot goes forward 9 meters, robot turns to the left. There you go. That's what pseudocode looks like. All right, so I'm going to just get rid of that for this one because, again, I'm going to kind of review that and go through those for each activity here as another quick review. So stay tuned for part 1, which we're going to start getting into the city of angles. All right, welcome back. Hopefully you took a little break, maybe got some high quality H2O. And hopefully that's my watch. I got a new smartwatch that's going off here. So, angles. I kind of want to get into some of the vocab of angles here. So I'm going to jump over to a different screen, and actually, no, not there yet. I'm going to jump over to here and go back 1, and I'm going to go to the vocab. So there are we're going to talk about various and sundry angles in here, and I want to review the vocab for that. So you've got acute angles. An acute angle, hopefully you remember, is less than 90 degrees. You've got your right angle. An obtuse angle here is 90 degrees or is greater than 90 degrees. And I'm going to add in a little something here, but less than 180 degrees. And there's a special reason for that, because I just learned today about a brand new angle. It's called a reflex angle. This is the angle that's greater than 180, but less than 360. I thought that was just a simple obtuse angle, but oh my gosh, OMG, who knew there was a term reflex angle? And you know who taught me that, or who I had to go to get that information? Mr. Bauermeister. Yes, the Bauermeister gave me that. He set me straight. He also, along with Ms. Krieger, shared this wonderful resource with me called, what is it? It's called mathisfun.com. Oh my gosh, math is fun! I love it, I love it, I love it! All right, so here with Math is Fun, I'm going to include this this website, this web link in the resources on the with the lesson here, so you can go into and take a look at these. But this site does a really good job of explaining the different types of angles: acute, right, obtuse. There's a straight angle. Who knew? A reflex angle, and full rotation. It does a really good job of allowing you to test out those different angles, kind of see what they look like, and then going more in depth. So if you're looking for, if you're just like, oh, how excited I was about OMG, there's like total number of angles, and I'm going to learn all about, you want to go more in depth in these angles? Bam, right you go. Math is fun. All right. So let's jump into, let's continue through the vocabulary. Yeah. Then we've got, so that's a reflex angle. Adjacent angles. This is just simply two angles that are together. They have a common side. So right here you've got A and B, there's their common side. And then another type of angle, a vertical angle. That's where they have the same vertex or vertice or whatever. The center point is how I'm saying it. So A and B are vertical angles, D and C are vertical angles. So those are all the different types of angles you're going to be running into. I may put some of these on the after party, or not after party, the after lesson quiz or form at the end of the lesson. So hint, hint, wink, wink, nudge, nudge. Anyways, those are the different type of angles you're going to run into when it comes to the city of angles. All right, so let's jump into mission 1. And mission 1 is going to be where I start part 2, which is going to be the demo session. And I'm going to demo these. There's going to be probably a few more parts than normal, but I want to demo these to try to make it a little bit easier. So part 1, we'll continue on with activity 1. All right, welcome back to part 1. Or this is part 3, I believe. Part 3? Yeah, part 3. And with this, we're talking activity 1. And you can see I already pulled out some things here. And I'm just gonna pull these away. And for activity 1, we got to get to wherever the magic dot is here. So if we went full screen, we could see it looks like maybe we're going down here. I don't know, well, yeah, underneath. So I'm going to go back to Explorer View, and I'm going to look at this and go, oh, okay, I got to go forward 3 meters. I got to do what kind of angle is this? What kind of angle is that? 30-degree angle, that's right. Okay, I got to go turn to the right 30 degrees and then go another 3 degrees. Now, you may think, why do I got to do pseudocode for this? Not necessarily for this one do you need to do your pseudocode. It's a good way for me to review it with you, but it is a good habit of getting into. Looking at some of your other some of you that turned in your pseudocode, I like the fact that you're keeping track of things that you've tried in those later on lessons. It will really make your programming better and and faster than if you just try to code it off the top. So, robot, forward 3 meters, turn right 30 degrees, and forward 3 meters. Okay, so again, now I know what I got to do. Okay, so I'm going to exit full screen, and I like to pull out my turns here, and then set the things that I need. And perfect, I got that. And then I'm going to do my data blocks, and I pull out all my data blocks. How you choose to do this is totally up to you, but I know sometimes I like to have pseudocode minimize that, bring that around here, and then I can see off to the side, all right, I gotta go 3, 30, and 3, and I don't know, how was that? God, is that screaming I hear in the background, or somebody telling me something in the background? I don't know. Well, let's see. Let's watch this here. Go full screen, and oh no, my robot fell. Oh, I did something wrong. Oh, I was supposed to turn to the right. Okay, so again, there's another way you can, if your robot does something that doesn't perform right, or it doesn't do what you want it to do. Let me go back to here. Then use your pseudocode to say, oh, that should be, why didn't it work? Oh, it should be right. Okay. So that's just pseudocode for activity 1. And you know that this is, I know, and you'll probably go, okay, well, great, I can do that. I'll just as a great review for that. Okay, so in the next one, we'll jump into activity 5, and I'm going to, let's see here, I'm going to come back to, so in activity, in the next part, I'm going to demo activity 5 for you. All right, welcome to activity 5. So we got our program start here. So activity 5, you've done some different types of turns and things. I'm going to open up Explorer view, and I'm going to go full screen so I can see this a little bit. So here we've got a thing here that if we were to zoom in, we got a little gate action here. We can't just turn and go forward, or maybe we can. But it looks like we got to hit that button first. So to pseudocode this out, it looks like I got to go forward 6 meters, and then, I got to come back. I don't know how much I've got to come back. So maybe I got to go backwards. Well, it's kind of half, so maybe backwards 3 meters. Turn, let's see here, I gotta go turn. Backwards 3, I gotta turn to the right, looks like right. Turns to the right 105 degrees. And then forward looks like 10 meters. So there's my thing here. All right, so let's see here. I know I need a total of 1, 2, 3, 4. It looks like 4 blocks. So I'm gonna speed this up a little bit, speed the video up here a little bit as I pull out my code and write the first part of my code, just so you're not watching me you're not getting bored watching me pull those out and set those up. Okay. Okay, so I'm gonna go ahead and I'm gonna go full screen on my computer here, and I'm going to, let's see here, let's go ahead and run the simulation and see what happens. So it goes forward there, I'm going by 6, it hits the button, oh good, turns that over, and oh, first mistake, I forgot to set that as backward. Alright, so let's go reset the simulation, and I honestly didn't mean to do that, but let's see, let's go back here. Let's try this again. Okay, so we're going forward. Let's speed that up a little bit here. So now it goes back 3, and all right. I'm going to stop it there. I am going to zoom in. So you can see here where turning to the left. Oh, and I'm going to stop the program because it's stuck in that program there. So I got to turn to the left here. So let's go back to my pseudocode and say, oh, turn to the. Oh, that should have been right. Nice job finding that out. Let's reset that simulation and go back here. So you can see how that pseudocode is coming in handy for your old teacher here. All right, let's try running that again. And there it goes, going up 4, and okay, well, you know what? It looks like that was correct. Except something's not right here, I think. So, this is where your pseudocode can come in handy. I need to make some corrections, but I'm not going to give you the answer here. Remember, we have this little tool here. If I reset the simulation, go back here. So I've got to figure out, let's go full screen here. So I got to figure out how to measure what, where do I need to come back to? Well, it might be worth making a measurement back to where you want to get the robot back to. Okay, so you'll notice that when I went back 3, half of that, it didn't quite get to the right place. So that's going to be the challenge, is to use that measurement tool to measure that distance to see how many meters you need to go back. Okay, so good luck with that. In the next part, I'm going to talk about activity 9 and how to use pseudocode to get through that. All right, so good luck on this activity, and I will see you down, oops, sorry about that. I'll see you down the road in the next activity. All right, here we go. Activity 9. Welcome to the next part. So activity 9 is you're driving along parallels. This is where we're talking about those parallel angles, and hopefully you've gotten through these. I'm going to tell you right now, these are tough. So we got parallel lines here. So we got a line here, and it looks like as we go back to here, it looks like, oh, no, all we got to do is go straight. So looks fairly easy to do, but let's pseudocode this out. Okay, so activity 9, it looks like, and again, I'll speed this up a little bit so that you don't have to, I'm not necessarily going to talk through this, but you'll see me do my pseudocode, and you'll see me transfer that pseudocode into code here, and then I'll jump back in. So I'm going to speed up. Okay, welcome back. So there I've got, oh, I forgot to add in that. I put the angle there, and then I went forward 2, or no, forward 3. Looks like 3 there. All right, so there you can see I pseudocoded things out, and I double checked, and I made sure I got everything there, and I'm gonna let you figure out and see if that works, see if this code works and gets you to the target area. But again, that's the power of pseudocode. You can see I made some mistakes earlier on to kind of show you that. With these simple programs, it's not that important to do pseudocode, but it is a good habit to get into. All right, so with that, good luck. I can't wait to see how you go through, and I am going to ask, though, that, let's see, I'm going to go back to the Learning Center. I'm going to ask to see your pseudocode for the final challenge, just so that I can get an idea of how you're programming and how you're doing. All right, good luck, go forth, and do great things.